After writing the 5 algorithms for the problem that inserts a new element into an array at certain index, now is the time to discuss the performance of each of them and determine which one is the most efficient algorithm. To make a room for the new element at certain index, all algorithms move the elements after this index either by shifting them to the next location in the array or copying them to a different array. And usually this is implemented by using a for loop that passes over all of these elements once. Therefore, we will first focus on how many passes each algorithm takes to shift or move these elements in the array. Then we will look for additional features and properties. The additional features and properties are simplicity, easy to understand, and whether it is an in-place algorithm or not. An algorithm is considered to be an in-place algorithm if it does not require extra memory, such as another array, except possibly for a few memory units. Let's go over each of these algorithms and discuss their features and properties. For the first solution, the algorithm shift writes all elements starting from the end of the array. The algorithm uses a simple for loop that passes only once over the shifted elements. That's why it is considered simple, easy to understand, and trace. The algorithm is also considered as an in-place algorithm because it does not need any extra memory. Now for the second solution, the algorithm starts shifting the elements to the right, starting from an index I. Similar to the algorithm for the first solution, it uses a simple for loop that passes only once over the shifted elements. But shifting an element to the right, starting from any index without losing its neighbor element, adds little complexity to the algorithm. That's why this solution is considered not simple and difficult to understand and trace. However, the algorithm is considered as an in-place algorithm because it needs only two variables p and q. And these two variables take little memory units compared to the memory units that are needed by the array. Regarding the third solution, the algorithm for this solution adds the new element to the end of the array and makes consecutive swaps from there until reaching index I. The features and properties of this algorithm similar to the features and properties of the algorithm for the first solution, except that it is slower because it does many swaps when shifting the elements to the right. For the fourth solution, it copies all elements that need to be shifted to a backup array, adds the new element at index I, and then it copies back the shifted elements to the array. The algorithm uses two separate for loops. This is why we say that it passes it twice over the shifted elements. The first time when they are copied to the backup array, the second time when they are copied back to the array. The algorithm is considered simple and easy to follow and trace. But it is not considered as an in-place algorithm because for the worst case, it needs a backup array that has the same size as the array itself. Now for the final solution, the algorithm uses recursion that moves the new element at the end of the array and starting from there, swap backward any two consecutive elements. The algorithm calls itself recursively, passes over the shifted elements only once. The algorithm is considered not simple because it deals with recursion and also not easy to trace. The algorithm needs recursive calls overhead. When this happens, it happens when the local variables and the parameters of the algorithm are pushed on the stack for every recursive call. The algorithm is considered as an in-place algorithm because it does not need any extra memory units for shifting the elements. After discussing the features and properties of all solutions, what is the conclusion of our discussion? In other words, which algorithm is the most efficient algorithm? In conclusion, the first algorithm is the most efficient algorithm among all the other algorithms. The reasons are: the algorithm is simple, easy to understand and trace, passes over the shifted elements only once, and it is an in-place algorithm. Now for solution 2, it lacks simplicity. For solution 3, it is slower due to excessive swaps. Solution 4 passes over the shifted elements twice and is not an in-place algorithm. And finally, solution 5 has excessive swaps and some calls overhead. This is why the first algorithm is the most efficient algorithm for this problem.